Hello, welcome to Econometrics Melody. In this video, we will calculate the inverse of 2 into 2 partition matrix. First of all, let us partition a matrix A. We have a matrix A and its order is 5 into 5 square matrix, and we partition it into 4 matrices, in which matrix A11, this is a square matrix of order 3 into 3, and matrix A12, it is of order 3 into 2, and matrix A21, it is of order 2 into 3, and matrix A22, it is a square matrix with order 2 into 2. Therefore, matrix A is equal to, in its partition matrix form, this is equal to A11, A12, A21, and A22, where each of the elements are the matrix. And the matrix in the main diagonal, they must be a square matrix, and the off diagonal matrices, they can be of any order such that the matrix A ultimately it should be a square matrix. And generally, matrix A, it is symmetric, and once it is symmetric, it is ultimately a square matrix. When we calculate the beta estimate, we have x transpose x, this is a square as well as a symmetric matrix. Similarly, while calculating the beta estimate in partition regression equations, the symmetric and square matrix is involved. So these are the cases of inverse of the symmetric matrix, and in order to understand the internal process, sometimes we need to partition these symmetric matrix and calculate the inverse of it. So this is the general way to calculate the inverse of any matrix, any square matrix A. So in a general or normal form, we calculate the inverse of matrix A making use of adjoint of a matrix A, and we divide it by the determinant of this square matrix A, and adjoint of A is the transpose of the cofactor of matrix A. Now we have our partition matrix ready, where the matrices in the main diagonal, they are square. So we begin with a focal point. Either we take the main diagonal element, that is matrix A11 is our focal point, or we take matrix A22 is our focal point, and both of the matrix A11 and A22 in the main diagonal, they are our square matrix. So let us calculate the inverse of matrix A11 equal to, first of all, we write the matrix itself, A11 minus, then after A12, after A22 inverse. So we have taken A11, A12, and if our focal point is A11, another diagonal element, so we take the inverse of it. Then after we complete the cycle after writing A21. So in this term, the beginning is 1 and we indate it 1 as well, and we completed this cycle in the clockwise direction, and we take the inverse of it. So it is this simple. So if we don't take A11 is our focal point, then we can take another diagonal element, that is matrix A22 is our focal point, and the formula to calculate its inverse is no different. So we write A22, matrix A22 minus, then after we begin with 2 and complete the cycle, that is we go to A21, then after A11 inverse, because as A22 is our focal point, then another diagonal element, we take the inverse of it. Then after A11 we go to A12, and we maintain this chain. So we begin with 2 and we end with 2, and in between we maintain this chain and we complete a cycle, and we take the inverse of it. So this is how we can calculate the inverse of matrix A22. Now let us calculate the inverse of the partition matrix when we consider matrix A11 is our focal point. So this F1, it is actually the inverse of matrix A11, and the focal point 2, this is actually the inverse of matrix A22. So when we consider matrix A11 is our focal point, then the inverse of matrix A11 is given by F1. So we place it over here. Then after first row and second column, we add the row and column. So if it is odd, we write minus, and if it is even, we take plus. So the sum of the row and column for this position, that is 1, 2, it is odd, so we take minus, and we begin with 1, that is our focal point 1, F1. Then after we try to complete the cycle, F1, it is equivalent to taking A11, then after A12, then after we take A22 inverse. Here we have started with the main diagonal elements. F1 is related with A11 and we indate with A22. Similarly, for this position, if we add the number of row and column, it is odd. 2 plus 1 is 3, so we take negative, and we take the transpose of A12. So minus A22 inverse A21, and we end at 1, that is our F1. Now if we take A11 is the focal point, then we take the inverse of of the other matrix in the main diagonal. Then after we take I plus. So for the off diagonal element, we completed the half circle in clockwise direction. Let us see, F1 is related with A11, A12, and A22. Similarly, for the position 2-1, we began with the main diagonal A22, A21, and we ended at A1. That is, F1 is related with A11. So for the off diagonal elements, we take only half of the circle in clockwise direction, and for the focal point, we calculate inverse following either F1 or F2. Then for other main diagonal element except the focal point, we take the complete cycle. We begin with A22 inverse and we write I plus, then after we try to complete the cycle. So here is A22. After A22, we go to A21, and after we need one A11, that is represented by F1. After A11, again we move to A12. After A12, we come to A22. So once we take A22, it is in its inverse form. So this is how we calculate the inverse of partition matrix A. And here we have considered matrix A11 is our focal point. Now let us consider A22 is our focal point, and the underlying process is no different. So this is our focal point. Now let me do a bit directly. So when the sum of the row and column, if it is odd, then we take negative. So here we have minus. So the place value, it is first row and second column. So for first row, is we have taken matrix A22 is our focal point. So the matrix A11 is in its inverse form, and after we write it is A12 and then A22. For A22, we write it is F2. Then after the place over here, it is 2 1, so we begin with 2, and in order to begin with 2 is equivalent to beginning with A22, so we take the focal point. Then after we complete the chain in clockwise direction, beginning with A22, we take only half of the circle. So from A22 we take A21, then after we write A11 inverse, or this is simply the transpose of this. Now as we have taken A22 as our focal point, so A11, this is in its inverse form. Then we take I plus, and as it is the main diagonal element, so we take the complete cycle beginning from A11. So in this matrix, if we begin from A11, then we write A12 over here, A12, then after A22. So A22 is equivalent to our focal point F2, represented by F2. After A22, we need A21, A21, then after A11 inverse. So this is how we can calculate A inverse if we consider F2, that is A22 is our focal point, and this is how we can calculate the inverse of a partition matrix A if we consider the diagonal matrix A11 is the focal point, and they follow the same process. So for the sake of understanding, let us practice it once again, and I'm going to first of all refer to the matrix A11. Square matrix A11 is the focal point, so I calculated F1 making use of this formula A11 minus A, and I complete this cycle. Let me say A11, then after A12, then after A22 is inverse because we have considered A11 is our focal point, and then we write it as A21 and its inverse. So ultimately, if we consider the values at the extreme, they are 1 1, and it is A11 is our focal point. Now let me position it. So this is the place for F1. Then after, when we sum the row and column, if they are odd, then we take it minus. The position for this element, this is first row, second column. So we begin with first, that is F1, and then again A12, and after A22 inverse, and we take the transpose of it to this side. It is again A22 inverse. A, the transpose of A12 is actually A21, and then we have F1 over here. Is F1 is our focal point, that is related with A11. So now A22 is negative, sorry, we take the inverse of it, A22 inverse, then after I plus, and we take the complete cycle. So we have 2 over here. We begin it with A21 and A11, that is our focal point, F1, then after again A12, then after A22 inverse. So it is this simple. Now if I consider A22 is our focal point, A22 minus A21, A11 inverse, A12. Here we have started with 2 and we ended with 2. So it is A22 and its inverse. So here we have focal point that is representing A22. This is the inverse of square matrix A22. So when we add the sum for these positions, they are odd. So we write minus. So the element, the position of the element is 1, 2. First row, second column. So we begin with 1. And as A22 is our focal point, so A1 A11 is negative, so we write it A11 inverse, and after A12, and for A22 we take the focal point F2, and the transpose of this, it is F2. The transpose of A12 is A21, then after A11 inverse, and here we begin with A11 inverse because A22 is our focal point. Then after we write I plus, we have 1 1. Now let us start with 1, A12, and for A22 we take the focal point. Then after we write it is A21, and after A11 inverse. It is this simple. We can calculate the inverse of 2 into 2 partition matrix. So let us partition our X. The first column, it contains the columns of ones, then after all other independent variables is X, and let us calculate the inverse of X transpose X because it is useful while calculating beta. We use this. So this is equal to I transpose I is, this is equal to n I transpose X, this is summation X, and X transpose I is also summation X, and this is X transpose X. Now if we happen to calculate the inverse of X transpose X, then let me consider it as a partition matrix. Now we can calculate the inverse of this A22. This is equal to, for A22, what do we write? This is X transpose X minus A21, this is X transpose I, and A11 inverse, it is I transpose I inverse, and A12, it is I transpose X. In the pre-multiplication term, we have X transpose, and in the post-multiplication term, we have X in both of these expressions. So let us take that common. And this is further equal to, if we concentrate in this expression, this is equal to I minus I, and in place of I transpose I inverse, I'm going to divide this by n, and we are left with this I transpose, and this is actually equal to our deviation from mean maker matrix. N is equal to I transpose I, and this is our deviation from mean maker matrix. So this is actually equal to, so when we calculate beta estimate X transpose X inverse, so if we partition that matrix, then this portion is actually giving the deviation from the mean of X. So we have seen this in our preceding video, the role of the constant term. Actually the constant term, it transforms both the dependent and independent variables into their deviation from mean. And this is going to be useful in our next video. Let us say we have a matrix W, and we partition it as matrix X, all the independent variable X except this variable Z. This is an individual variable, and matrix X, this is the matrix of all other independent variables including the constant. And if we happen to calculate W transpose W and its inverse, so this is the case of the inverse of 2 into 2 partition matrix. And for the time being, let us calculate the inverse of this portion, that is A22. Again, A22, this is equal to Z transpose Z minus A21, it is equal to Z transpose X. A11, it is X transpose X inverse, and A12, this is equal to X transpose Z and its inverse. And let us focus on this internal term only. So this is Z transpose Z minus Z transpose X, X transpose X inverse, X transpose Z, and we have again the pre-multiplication term and the post-multiplication term. They are common, so let us segregate it, or let us separate them, and let's take the remaining part. So it is X, X transpose X inverse, X transpose, and this much X, X transpose X inverse, X transpose, this is our projection matrix. So it is equivalent to I minus, let me write it as P. So I minus P, this is our error maker matrix, and Z. So this is equal to Z transpose MZ inverse, and this gives the residual, that is we partial out the effect of X from Z. So MZ, it gives the residual when we run a regression of Z on X. In other words, we are partially out the effect of X from Z. So this is the residual when we run Z is the dependent variable on X. This X for this context. So the calculation or concept of inverse of 2 into 2 partition matrix is very useful to understand the internal melody or the internal process of the mechanism in econometrics. Now let us see whether this formula is true or not by the help of example in Stata, actually in Mata in Stata. So we have our data set ready with 21 observations, and we have our dependent variable y as well as 7 independent variables, and we're transporting these variables into meta. We use this syntax called put meta, and we're transferring our variable dependent variable age will is the independent variables along with the constant term, and it is represented by matrix X. And now we are invoking meta, and we want to display the list of the matrix dependent variable y as well as the independent variable in matrix X. And we construct a matrix A that gives X transpose X, and we will display it as well as we will calculate the determinant whether the matrix X transpose X it is singular or not. So 21 observations, this is our dependent variable y, and the matrix X, this consists of the constant term as well as 7 independent variables. So in total it has 8 columns. Then after A is equal to X transpose X, and it is symmetric. X transpose X is of order 8 into 8, and it is symmetric. And as the determinant is not equal to 0, so this matrix A, that is X transpose X, it is non-singular, and we can calculate its inverse. Now let us partition this matrix into 2 into 2 matrix, where A11 we take a 5 into 5 matrix, and A12 it is 5 into 3 matrix, and A21 it is 3 into 5 matrix, and A22 it is 3 into 3 matrix. And we construct a matrix B considering these matrices as the elements, and we check whether A and B whether they are same matrix or not, and we take the difference of it and we get the value at 0. A and B are same, where A is the original matrix X transpose X, and B is the partition matrix, and their difference is obviously 0. Now let us calculate the inverse of A making use of this syntax in sim, and we are making use of the general formula to calculate the inverse of A. So this is the inverse of A. Now we want to use the formula to calculate the inverse in case of 2 into 2 partition matrix, and there are 2 ways. First of all, we take A11 is the focal point, and we position them in their appropriate place, and this is equivalent to calculating the inverse of matrix A, that is X transpose X, making use of the partition formula. So let us run this and check it whether we get the same result or not. So this I inverse of A using 1, that is A11 is the focal point, so we get this inverse, and IA, this is the inverse making use of ordinary formula, and if we compare them they are one and the same. And if we take the difference of these two, this is equal to 0. IA minus IAF1, this is 0. Now let us calculate the same, but this time we are going to consider A22, that is matrix A22 is our focal point, and we are going to calculate the value of F2. F2 is equal to A22 minus A21 into A11 inverse A12 and whole inverse. Similarly, we calculate the respective values for position 1, 2, 2, 1 and 1, 1. And we place the respective components in the matrix named IAF2, I for inverse of A using F2 as the focal point, and then we display the inverse of matrix A making F2 as the focal point as well as the inverse of A, and we compare the differences of the inverses we have calculated making use of different methods, and we get the same result. So this result, it gives the inverse of matrix A considering F2, that is A22 is the focal point, matrix A22 is the focal point, and this one at the bottom, this is the inverse of matrix A making use of the general formula. Now let us compare them. So they are one and the same. The difference is 0 because they are one and the same. And the difference of inverse of matrix partition matrix A considering F1 is the focal point or F2 is the focal point, they are also one and the same. So once again, inverse of a 2 into 2 partition matrix is very useful to understand some of the important concepts in econometrics. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.